Welcome, everybody, to the Distill Buildings Tech Podcast.
Where smart buildings are stirred, shaken, and data-driven.
Awesome. I'm your host, Jason Shear.
I'm your host, AK.
And with us today, we have Olivier from Electricity Maps. Olivier, welcome to the show.
Thank you. Pleasure to be here.
Yeah, excellent. This is a conversation I've been looking forward to for a really, really long time, having been an Electricity Maps fanboy for quite a while. Can you tell us just like a little bit about your history, like education, like how you got to where you are today?
Yeah, sure. So I'm originally, I studied applied mathematics. Basically, was just always super interested in how computers could leverage math in order to create magic in the world. And I studied math. I went into machine learning afterwards. And for me, energy was always the space where you have real-time data. Everything is real-time, especially with so many renewables coming onto the grid. And this was just a perfect way to apply my skills. And I wanted to play at the intersection between IT and energy. Mm-hmm. I ended up studying applied statistics afterwards in my master's, tried to apply these things together with IBM research, where I spent a bit of time. I did a lot of research on how you could simulate vast electricity grids under like a very high penetration of renewables. I don't know how nerdy you want to get about this, but spend a bit of time doing control systems as well.
Keep going.
We're both have engineering backgrounds, so we can totally geek out. Yep.
So basically my master thesis was about how you could use a control system that would generate electricity prices in order to get the desired amount of load on the electricity grid. So basically say, let's remove markets and let's imagine instead there's a machine that generates the right prices to get the right response. And it was fascinating, and I spent a bit of time there. Spent a bit of time at IBM Research, as I mentioned, simulating these grids. And IBM was great, but it was still like a very big, old engine, so to speak. So I went into Google instead, worked on Google Maps over there, a little bit on energy stuff as well. And at some point, I just realized the amount of responsibility right now that I'm given is insufficient compared to the hunger that I have to just create stuff. And so I left there, joined the early stage startup in Paris. We were building AI systems that would run on your device, a little bit like trying to replicate Siri, but running on the device. Well, I learned a ton of computer science stuff and math and ML, but didn't really work in this energy space anymore. And after that, I left. And this is almost 10 years ago that I left. And I wanted to get back into, energy and intersect that with data. And then I started looking much more at climate change, read everything I could, IPCC reports, and I realized, oh my gosh, like no one is talking about this, and this is massive. And this was before, loads of people were talking about climate. And I said, I must try to distill everything that I know and get all these tech folks that I've been hanging out with, to understand how big this of an issue this is. And so I founded a company that was called Tomorrow, that was really put into the world to build the Google of sustainability, because I had this thesis that information about climate change was very difficult to digest. And if you could do what Google search had done to the web, but do that for climate, make information accessible and widely useful, then, that's a super scalable way to start tackling the issue. If you have people building products based on information, then, it's pretty impactful. And build a couple of prototypes, different products, and we can talk about the other products if we're interested. But Electricity Maps was one of the first things that I built there. And, a couple of years down the line, renamed the company from Tomorrow to Electricity Maps. And then it grew. And now it's, what are we, like almost 40 people based out of Copenhagen in Europe, building this and working with some of the, biggest companies in the world, like the Ciscos, the Googles, and the Microsoft, and so on.
That's quite the journey in a relatively short period of time. Being in Denmark, I think one of the most one of the highest rated renewable energy like producers in the world. Did that have like an influence on the interest around energy and carbon intensity?
Yeah, absolutely. So during my studies, the professors I was working with, I basically asked them, do you have any cool research projects I can work on? And a lot of the research projects they had, which involved time series information and real-time data, were all about wind power forecasting, because it was one of the first countries to experience what it means to have that much renewable in the system. And you need to be able to forecast it in order to be able to balance the grid and reduce the need for fossil fuels. And for me, forecasting was kind of this thing where it's a bit magical. You put in a bunch of zeros and ones and data, and then some algorithm will be an oracle and spit some information about the future. Like, how the heck does that work? So I was always fascinated by that, and this is where I applied it. But the funny thing is, I have I'm born and raised in France. I have my father is French, my mother is Danish, and I've sort of always been in both countries. And the interesting piece is that Denmark is a highly renewable country. And then you have France, which is exactly the opposite, sort of hate renewables, always been like heavy nuclear. Most of the electricity is nuclear in France. And so I've always been in this, in these two worlds.
Kind of between worlds.
Exactly, yeah. And in between a lot of debates that actually has happened with electricity maps. And, should the world be 100% nuclear or should it be 100% renewables? And I'm like, guess what? The answer is a little bit of both. But
both.
Yeah.
Awesome.
That's cool. So as the audience know us, so next drink or choice of drinks that Olivier came up with is a little bit complex than what they're probably going to see in the past episodes. So why don't you tell us what your favorite drinks was?
It's actually a whiskey sour, and I'm happy that I'm bringing the bar up as we were mentioning earlier. But I really really like this combination of sort of the the sour piece and more of the bourbon together with a bit of egg white, which creates this nice foam at the top. It's perfect.
Yeah,
that's awesome.
Awesome.
Cheers to that.
Cheers. Yeah.
Cheers, guys.
Do you have a specific bourbon that you like mixing into your whiskey sour, Olivier?
I'm not that fancy. I should
not that
probably,
fancy.
But I'm not at that level yet.
Yeah.
But I should probably at some point, if I'm being honest.
You did
Very
get
cool.
the foam right, though. I mean,
Did
mine looks
yeah.
a little bit diluted, and yours looked like there's that thickness of foam up there.
Yeah, you got to really shake it really well, and then at the end, you have to. The foam is going to be at the bottom, so you gotta really, really continue pouring it, even though you think there's nothing coming out. There's no foam is the last thing to come out.
Yeah. My wife and I have been experimenting with a lot of egg white cocktails over the past couple of months, and the hack or the trick that we have found is the dry shake. So shaking it with no ice and for a while, and that kind of develops the foam, and then putting ice in it and shaking it a little bit more, and that chills it. So yeah, there's definitely tricks to getting that nice foam layer at the top.
That's a good
And
tip.
do you add the sweetness of the cherry? Do you stay away from that? What's the combination?
So I actually like putting a little bit of sweetness and including the cherry if you can. I didn't have any with me right now, but else I would have definitely. So yeah, I saw you guys have it. Yeah, you're really pulling it off, man.
I just followed the recipe. Yes,
That's a good way to do it.
Yeah.
Great. And from your inspiration of electricity map, maybe tell the audience just in from 1,000 foot up, what is electricity map at all? What does it do? What's the services that it offers, and what's the product?
Yeah, so really the place where it started was to say, the world is moving towards more renewables on the grid. So we got to look in real time at where electricity comes from. Really, the starting point for all of this was I was reading the news and I saw this news that Denmark had ran on 100% renewable electricity for a day. And I was like, oh, really? Okay, so what about, yesterday and tomorrow? What does that number look like? And so started gathering a bunch of data, created a data visualization that just showed this in real time. And then afterwards, it really started to take more of a life of its own, realized that this can be leveraged in order to tell all flexible devices across the world, whether it's a dishwasher, washing machine, an electric vehicle, a data center, heating systems, what is the optimal time to use electricity to make sure that you use electricity when it's clean and not when the dirty fossil fuel power plants are running. And so, where we are now is we've moved far beyond just this nice data visualization that we had originally. Now it's this comprehensive data platform which provides all of the electricity grid signals that you need if you want to build any cool use case on top that that interacts with the electricity grid. A simple way to think about this is if you pick any location on the globe, then we'll tell you in real time everything there is to know about the electricity system, where electricity comes from, how it's generated, the electricity flows, the electricity prices, how much carbon is emitted, how much renewable is present. And we're doing that historically. And that's typically if you want to do carbon accounting, then you need historical data. Real time, that powers quite a few interfaces. There's apps out there that are leveraging our data. And then the predictive piece, like predictions up to, a week ahead is our ambition. Right now, we're only at a couple of days, but pretty soon we're going to be at the week ahead. And this enables smart scheduling. As I mentioned, these dishwashers, you go home, you press a button, it just dumbly runs immediately. What if it knew that in 2 hours would be a good time to run because it could save you money and it could save a little bit of carbon because a power plant is not going to have to burn some fossil fuels as a consequence. So it's a data platform. That's really the ambition, and to give you all the electricity signals required to build any cool use case on top.
Cool. So it's really like when you go to electricity maps, like the first thing you see is a beautiful reactive interface, but the real power is leveraging like the API to take that data and synthesize or correlate that against like other data sets that a customer might have.
Yeah, absolutely. We're, another way to look at this is that we're trying to build the Google Maps of electricity. You have like this emerged tip of the iceberg, which is the physical world that we're trying to represent. Pretty soon on electricity maps, you're going to be able to see, for example, the location of the big data centers. So it's really trying to be this Google Maps where you can visualize anything that interacts with the electricity grid. And underneath the maps are, this powerful engine, the data layer, and that we're making it accessible for other companies who want to build use cases on top, like smart dishwashers, smart data centers, whatnot.
Yeah, you mentioned both aspects, interior, inside the building and outside the building. So what's the vision for the next year inside the building, and what's the vision outside of the building? When you look at the electricity, there's a consumed electricity inside, and then you have obviously the power plant sharing power between each other. Is electricity map bridging those two together? Is the vision to do that?
Well, so I think what we do is that we want to represent as accurately as possible what's happening on the electricity grid and make sure that the orchestration between, let's just say, like outside of the home, inside the home, or inside the building works as well as possible. And that really means two things. It means, one, providing the right signals so all the devices are making the right decisions. And if you want to do that accurately, you need to have like a very, very detailed picture of what the electricity grid looks like. And for the past couple of years, we've really been focusing on carbon emissions, focusing on the emissions of the grid, helping all these devices utilize electricity to maximize, the emissions reduction possible. And what is going to happen in the next, year and couple of years is that we're expanding really to give other signals, such as the electricity price. I mean, who doesn't want to tell a good story about, I was able to reduce my electricity bill and I helped the environment at the same time. No one says no to that, right? It's a perfect story.
Yeah.
The second piece as well that comes after is sort of, can we help the grid operate more efficiently? So stuff like grid alerts. There's a couple of periods, times during the year where a grid operator will have its electricity grid reaching sort of maximum capacity. For example, all their air conditioning system is going to be turned on because it's like the hottest day of the year. And that's the worst time of the year to be using electricity. So if we can make it simpler for everyone as a citizen, as a company, to see these events, predict them, then you're going to help the grid as well. So grid alerts is also a piece of that, of the picture that we want to try to put in. And if we manage to do that, is already like a pretty big effort, especially since we're trying to do that globally. And that's really the big feat here, is to be able to do that on a global scale, one API for the world. That's really the hard thing.
That's fascinating, because we talk about interoperabilities and smart buildings, and our challenge as Jason and I is really to focus on customers' journey when they're looking at global expansion. Our journey is all on Ethernet, right, which is the global adopted, and kudos to you trying to do that globally. And how do you manage creating that global API around the world, given obviously you have language challenges, culture challenges. I know the dollar is the same, right? It's all currency is the same. Somehow or another, you're paying for energy, right?
Oh, absolutely. Well, the honest answer is we didn't even try to do it ourselves because we knew it would be impossible. So something that worked really well in the early days of electricity maps is that only a couple of countries had actually a color on the map, meaning we have data for that particular region or area. And there was a call to action when you were hovering over an area where there wasn't data. Basically said, if you know where data is available, or if you're a coder and you can help us build the integration. Then click here, and it would take you to GitHub, and we'd had these guidelines of here's how you can build a very simple Python script that will connect to wherever place contains the data we're looking for. Here's how to format it in the output so we can understand it in a standardized way. And then as soon as you do that, we'll digest it. I mean, of course, we'll review the code first, but then we'll ingest that data, and it will appear as a new color on the map. So the bottom line is by having open sourced the data integration side of things, and by having an app where the call to action was extremely clear, the contribution pathway was relatively simple, then it just meant that we had some Indian folks that were helping us put Indian on the map. I remember reviewing a pull request with some Korean data, and I tell you, I have no idea how to read Korean.
Yeah, Korean.
But, we had someone who did that for us. And then one day, someone had built a translation system for the app as well, because they just wanted it in their own language to be able to showcase it to friends. And then people started to contribute with translations. And then you get this snowball effect of the flywheel starting to turn. So the community approach can be extremely powerful if you give some clear rewards and a simple pathway to contribute. Because there's a lot of folks in the tech world who have a bit of spare time, who want to help out a cool project, but it needs to be time boxed, it needs to be simple. And it turns out that lots of people work in the power system industry. So if we could just touch them, then they would be happy to contribute, right?
Yeah. Sure. What has been so thinking about this from like a big data problem, right? And leveraging open source and community to contribute different data sources. What's been the biggest challenge around, validation and normalization of that data?
I guess one piece of it is having clear definitions. One example is biomass is something that, depending on which country you're looking at, they will all have different definitions. In some countries, it includes, for example, burning waste. What do you qualify as waste, and so on and so forth. So having this like simple yet precise definition of what goes into each category is definitely one challenge. The other is it's more difficult than it appears to have clear definitions of what constitutes a data point that can be trusted. It turns out that you have data providers like grid operators who always apply a certain amount of modeling or estimation to the data that they're producing, even if it's just a tiny bit. They will apply some modeling. And on the other side of the spectrum, you can have data that's like completely estimated, like a model that's just running out there estimating based on weather data what they think the production is. Where do you draw the line of what's trustworthy for us to bring inside our system? And then afterwards, this is not static. It changes over time, meaning that from one day to the other, suddenly you have a data provider that's only going to report half of the wind produced because suddenly they've lost telemetry to half of the wind turbines. How do we, from our perspective, differentiate between a situation where there's not that much wind production and a situation where only half of it is reported? And so you need to little by little start building more intelligence into the platform to make sure that we can be smarter about detecting what is a wrong situation and what is an actual data problem and what is just an anomaly from the power system that we actually want to cover. I have a great example actually of something that just happened in Europe not too long ago with the Spanish electricity grid.
I had that on my list. I was like, we have to talk about Spain.
Well, let's talk about Spain then. So the grid went down, and in the beginning for a couple of minutes, I think for 15 minutes or something like that, our systems genuinely believed this was a data problem. It possibly cannot be that everything went to zero. So it must be a data problem. And then our system started to generate artificial data in order to make up for the fact that the data wasn't trusted. So it's taking over. And then very quickly we realized, oh wait, this is an actual outage. Let's very, very quickly intervene here and to make sure that we're letting like the real data go through. And now we have, we've built another layer of different anomaly detection models that are going to be able to detect these kind of things. But the point is, it's very difficult at scale, completely automatically, to have a system that can assign a certain trust value to a data point And because down the line, our customers, they're paying us to have like this single API globally trusted across the world. And sometimes we make mistakes, right? This was an example. But then we have to learn from it and build a better system afterwards.
That's a great model. And for the audience that doesn't understand, how does electricity map, Olivier, transacts? What's the business model? Is it API driven, consume API, or just what's the business model look like?
Yeah, so as we mentioned before, there's the emerged tip of the iceberg, the visualization. That's completely free to everyone because we don't want to put any barriers to how information, flows in the world. But the API itself, this is a paid product that we have. Um, Large customers are buying this as a subscription model. They pay us a fixed fee on a yearly basis, typically, then they get access to the API, and that they're able to use it in order to build other use cases on top of what they're doing. So that's typically the way that we work. But we are considering actually having a different set of products that are not only the API that could be monetized as well, because we just realized there's so much potential behind what we're doing actually.
Totally. I mean, if once you get into the regional and then you get to the smart cities of the world, that sharing that information across buildings, it's fantastic. It's actually what we always dreamed about, where the building next door can actually leverage or understand what the building next to it is doing in the cities, and it trickles down to countries, and you're doing it at a global scale, which is really, really exciting.
How did, from a in that was one thing I was thinking about. AK is a lot of the data that's contributed to electricity maps is probably like municipal generation, right? Like commercial generation of electricity and consumption of electricity. Olivier, like how do we take it a step further, and for for either individuals or companies that are doing their own like on-site generation, is there a way to kind of like insert that into the data lake to be reported on?
Yeah, so the as a startup, one of the trickiest thing to do is always to say no to things and to focus on one particular
Yeah,
thing. So
yeah.
something that we
Okay.
decided pretty early on was to say we're not looking at what happens, in your home behind the meter.
Hmm.
We're only reporting the grid's perspective, and that means that if you have a data center and you have some, local generators, you will need to add another layer to our data, which
Hmm.
is, our data is applicable when you're consuming from the grid. If you're consuming from your local systems, then you got to set up your own system for that. But it's a step that I'm always dreaming of taking in the future.
Hmm.
Some of the things we're starting to look at is mapping out all of the assets in the world, because there is a lot of open information out there about where all the assets are, and many of them are behind the meter. And it would
Yes.
be a shame not to represent that as well. There are some countries that have a very large amount of renewable generation, which is behind the meter and which is not necessarily mapped on electricity maps because then that doesn't directly feed into the grid.
Yeah,
That's a shame to not being able to map it outright.
Yeah,
yeah.
I see smart energy in the building space where we are. So, traditionally you had no idea as a building owner each and individual consumptions. You just know that you had a meter running, and then you get the total consumption, and then you times the kWh price, and then you have to pay that bill. Now in intelligent space, you have physically separations between each individual endpoint, and you can actually measure it. If that information can flow back into electricity map, and now you could do it at scale, meaning multiple headquarters, multiple companies, and you can normalize it by customer, then you can cross check against what you're actually consuming. That gives you that level of reality that you probably wouldn't have before.
And that's really what gets me excited about the future as well, is that I think we're still scratching the surface on what's possible here. If you think about it on electricity maps, what you have is a pretty, we have the geographical coverage, or sorry, the geographical resolution of the data
Hmm.
is not hyper granular. We could go so much further. We are not looking at the city level. We're not looking at the street level. This is something that the system would easily scale to that. The data is really the limitation there. We don't have telemetry data at that particular level where it's not real time, and we are always thinking internally whether or not we should try to bridge that gap with some of the models that could help us estimate. There are some interesting research publications that looked at a whole region and looked at the flows of electricity outside and inside this region, looked at the amount of production there is in the whole region. And if you start knowing the topology of the network inside that region, you know exactly which wind turbine is generating what, then you can start estimate pretty well, what the flows look like inside this region and how much of the wind energy actually makes it into your own home versus, another location, which is maybe, a couple of miles away or something like that. It would require a different level of computation, and we have to make sure the methodology is right and so on. But I see that as part of the future steps that will inevitably will be able to take as more data gets published, right?
Yeah.
True.
And like one thing I wrote down was like early warning system and like predictive, failure analytics. Imagining a world where whether it's a producer or a consumer has that forecasted data and they know whether or not they need to bring on, supplemental gas turbines because it's going to be a cloudy day or like a low wind day. Are you seeing use cases where producers are using that data to make those decisions?
So we are starting to get into the predictive realm more and more, and we're starting to work with producers that are interested in this information exactly for the use case that you described. I think the thing that we're trying to do, because there's many folks that do that already pretty well, to be honest. They do that at local scales, but I think what no one has been able to do is to take that at a really global scale. And that requires us to build systems that are scalable from day one. Like if it doesn't work in all the different regions at all the different levels of quality of input of the data that we're going to get in, then we're not doing it. And I think that being able to work on higher spatial granularity globally is something we want to do. It's still not completely doable right now, but I definitely foresee a future where you will, for example, be able to live stream information about a particular plant in one location, which is receiving, a cloud over it, and therefore cannot produce solar electricity. And we know the direction of that cloud, and maybe a couple of minutes later, it's going to be next to a different plant. And then you have like one of the best forecasts if you can put everything in the same platform. So it's really this game of, can you centralize all of the data? Can you start building synergies from them? And this is really where it starts to become exciting.
Is there regulatory challenges or landscape that you have to navigate when you're talking about a global scale? I think of the U.S. and I just can't overcome the regulations of just between. I live in Jersey and our office is in New York, and just those two cities, you have so much to go through. How does that apply to you?
Yeah, we've been actually lucky on that side because the regulatory landscape has helped us a lot by creating a legal framework that, let's say, motivates or creates a framework for data providers to actually publish this information, so we don't have to do the heavy lifting of going to someone, convincing them that they need to open up the data, make sure that there's no compliance risk or security risk to that data, and then get access to it. So most of the information we get is actually open data, or it's data that we're collaborating with customers. But in some sense, the regulatory landscape has really helped us because it's pushed regulators to open up more of the data. We've seen that especially in Europe. There's an energy directive in Europe that mandates that every country has to publish in real time, a certain list of signals from the electricity grid. And the newest directive is just pushing that to a different level, providing, access to smart meter and interoperability and so on. And I foresee that we'll just continue to go that route because a power grid is a shared asset paid by, a lot of the taxpayers in the end.
Yep.
So if you can create a system that rewards more innovation, lowers the price for everyone, and what better way to foster innovation than put data out there and let people build, cool new technology on top of it. So
yeah, and that kind of goes back to kind of the roots from an open source standpoint and thinking about like crossing geopolitical boundaries. Like you guys almost make yourselves a Switzerland of like the source of truth data.
I like that.
Yeah, that is awesome.
That's fascinating. Imagine a world, an ideal smart city or smart globe. How does Electricity Map want to be in it, or what do you see Electricity Map playing in?
Yeah, the vision that I've had actually since I studied energy was really to have I mean, just imagine for a second, if you look at all the devices or systems in the world that have a little bit of flexibility, can basically change the time at which they use electricity. I
Mm-hmm.
want all of these devices to help the grid decarbonize faster by utilizing renewables when they're available. And that's really the end goal, I think, because it's easy to decarbonize the grid with renewables in until you get to 60-70% renewables, because you can just add more renewables on the grid. But the last 30%, that's super difficult, because you need all these backup systems to be there for the rare times where there's going to be no wind and no solar. And this is where the smart city promise comes into play. Like, you want this energy grid to start sending, or to collaborate with all the devices in buildings, in homes. And we did a study back then where heating in buildings, if they were operated in a smart way, they could reduce by 20% your emissions and your
Mm-hmm.
electricity bill. If you think about how much of it is currently not instrumented that way, that represents a massive untapped opportunity. And the only thing we need to do is connect these systems to the internet, I almost want to say, right? We don't need to do much more. CapEx is very limited on these
Mm-hmm.
things. You
Yeah.
don't need to spend a lot of money. So for me, the promise is really this flexibility piece. Everyone has been talking about it, but I haven't yet seen it deployed on a large scale. And I think we're starting to see the first signs that it's starting to get deployed, and especially with the AI wave that's exploding,
Yeah.
I think we're going to see much more of it in the next couple of years.
Absolutely. And when you think about, on-site storage, like we see a lot of customers, particularly customers that have like a tiered rate schedule from their utility company, putting on-site storage in place so that they can do rate trimming. And then they're filling that on-site storage back up from the grid at either low rate or low carbon intensity times. But having that data to be able to make those decisions is probably the most important thing.
Yeah, you're going to need the data, and you're going to need like the prediction models and the
Yeah.
optimization algorithms afterwards,
Mm-hmm.
right? So it starts with data, and then you have predictive capabilities, and then you have optimization capabilities afterwards. And you need these three things to work together if you want to pull things off. But it's very, very impressive to watch the uptake of storage in
Mm-hmm.
the past couple of years. Absolutely
Yeah.
impressive.
Yeah.
And I got to tell you, it is truly the ESS systems, energy storage systems are skyrocketing. We're seeing customers. I mean, the DC infrastructure being the future is a no brainer in a lot of buildings that we see, because of it's just the nature of having the data and power all in the same bus. And all our devices are already DC natively built. Why not just store the energy DC? You harvest it in that fashion anyway and deliver it in that fashion. There's no reason for conversion, because you lose the efficiency, and you lose a lot of it just by doing the conversions. And I think that intelligence between when can I use the energy and what time, and the ability to know that at real time, it's massive. It's huge when
Absolutely.
it comes
Absolutely.
to delivery.
Cool.
Absolutely.
Well, Olivier, this has been a really awesome conversation. Like I said, I've been looking forward to it, both from a personal side, because I'm a home automation nerd, and I first found out about electricity maps like through the home assistant integration, to be able to tell myself like what the carbon intensity of the energy that I'm using. And that's given me the ability to go out and have that same conversation with customers. So what's the best way for whether it's a customer that's listening, or maybe another manufacturer or ISV, like what's the best way for them to find out about electricity maps and the capabilities that you guys have?
Yeah, I think the easiest is probably to go check out our website and check out our products. And when I say products plural, it's because the map that we've been talking about is certainly one place to get a little bit more acquainted with exactly what type of data we have. But we actually have freely downloadable data sets as well that you can download if you want to just build a small prototype. And Home Assistant is definitely one of the shout outs, one of the best open
Mm-hmm.
source projects that I've seen around, where you're not the first one to hack around in their home and use electricity maps for that. But
Yeah.
this is also the kind of use case that we want to be able to empower.
Yeah. No, awesome. The other thing I'd recommend for folks to do is like follow electricity maps on Twitter. Like that was actually how I learned about the Spanish outage a couple of months ago, was you and the team posting your data on Twitter around that outage.
Absolutely. We try to engage as much as we can on social media. Well, you wouldn't believe the amount of interesting stuff that happens globally on electricity grids. And I think at some point we should try to have a stronger social media presence to tell more of these stories. This one was too big to miss. So, we had to tell something about it.
Yeah.
Awesome. Well,
Cool.
for folks that listen to us as usual, like and subscribe. And really, it's a pleasure to talk to you, Olivier. And I think it's an interesting topic, and it's really great product.
Well, thank you so much. I appreciate the support.